Okay, so today's lesson is going to be on unit rates and using what we have learned in previous lessons to solve unit rates. We'll be putting it on page 81, and the date is 10/10 of 17. Once you get that into your book, please make sure you turn to the page that you're going to write unit rates on, and we'll get started. So let me fix this for you. All right, so a unit rate, I've already briefly talked about it in the previous lesson, is a rate that compares by division of two quantities that have different units. For example, you have miles per hour, which we use for driving. So miles per hour is typically seen as mph, and you would put miles over hours. When you're looking at cost for an item or cost of an item, it's always written with cost on top and then whatever item you're comparing it to on bottom. I gave examples in class of like cost per gallon or 4 gallons, cost for an item as in like going and buying chips. You can get those multi-pack variety packs of chips and you can see how much each bag costs in the bag. All right, so the unit rate is a rate in which the second quantity is 1 unit. The key words you're looking for to find for unit rate is per or each. Most of the time they use per, like in miles per hour. I could say cost per item. And that really is typically what they use to when they want you to find unit rates. And so whenever you see per, which is meaning division, you're looking for the 1. All right, to solve for a unit rate, you can set up a proportion, which is an equation that states that two ratios or rates are equivalent to each other, okay? When it's equivalent, that means we have an equals bar, all right? So in this, we have two ratios or rates, and I just put A, B, C, D, just as, to get us started on what the proportion looks like, where when you cross multiply to start solving to see if they're equal, you would have A times D equal to B times C. The equal sign meaning both sides are equal to each other. This is just like when you compared fractions back in elementary school. You were seeing if one side is bigger than the other. Well, this time we're looking to see if both sides are equal, or we're trying to make both sides equal to each other. All right, so that's on proportion. Here is an example that we can look at, and we have, if there are 16 campers for 2 cabins, how many are in each cabin? Well, when you set up your proportion, you have 16 to 2 or 16 for 2 cabins. We want to know how much are in each one. And so you would do the cross multiplication, 16 times 1 and 2 times the x, and you get 16 times 1, 2 times x as a one-step equation. When you solve for this one-step equation, you get 16 divided by 2, which is basically what we started off with in our proportion. And then we know that we get 8 campers for 1 cabin. Okay? Another example. We have detergent cost $4.80 for 32 ounces. How much does it cost per ounce? I underlined cost per ounce because this helps us set up our proportion, cost per ounce. So we know that the cost is $4.80, and we are going to set up our proportion for 32 ounces. So $4.80 per 32 ounces. So we want to know how much it costs for that 1 ounce. When we cross multiply, we get $4.80 times the 1 and 32 ounces times the x, because we're looking to see for the cost of 1. Then it sets us up for a one-step equation. In order to solve for x, you would divide by 32 on both sides. So you have $4.80 divided by 32, and you should get 15 cents for the 1 ounce. Okay? So this states that the cost of detergent per ounce is 15 cents. Sorry, it's getting like crazy over here. I'm trying to talk through this and keep everything straight at the same time. All right. So detergent costs 15 cents per ounce. So setting up the proportion based on the question, cost per ounce, and then you cross multiply to solve. Or you can simply do your division, $4.80 divided by 32, and that gives you 15 cents for the 1. All right. Now we're going to get a little more complicated. Let me get this straight so that I don't have to move so much. All right, so we're going to look at some complex fractions in the unit rates. This is where it can get a little crazy. All right, and you have to remember what you've used in previous lessons weeks ago. All right, so say we are needing to paint, or we are painting, and we can paint 55 square feet for every half hour. Okay, how many square feet do you paint per hour? Well, half hour is a 1/2. Okay, we don't want to change to minutes. We want to use our fractions. So determine the unit rate. And determining the unit rate, we're going to say that the area in square feet per time in hours. So we have area over time. Okay, so that's the first rule of thumb, is to determine the unit rate. In this example, it's the square feet or the area over the time. Okay, the second thing is you're going to use your original statement to set up your rate. So your original statement here that I've underlined in blue, 55 square feet for the half hour, is right here. Okay, 55 square feet for the half hour. And then you're going to equal it to what you're trying to look for. You're looking for how many the area, how much you can do area-wise for 1 hour. Okay? You're going to solve this just like we've solved with the whole numbers. When you cross multiply, you get 55 square feet equal to the 1/2 times x, which ultimately means we're going to divide by the 1/2. Okay, so 55 divided by a half. Okay, so finding the unit rate, we're going to do 55 divided by the half, all right, which equals 55 divided by 1 by the half. We can use KFC. This is what I was talking about by using your knowledge from previous lessons. When you have a whole number, you put it over 1. You keep the first fraction, flip the second fraction, change the operation to multiplication. So here we're going to change 55 over 1, then times the 1 over 2. And you should get 55 times 2 equals 110 square feet. And 1 times 1 is your 1 hour. So we know at this point that we can paint 110 square feet in 1 hour. We're going to do a lot more examples that are just like this in class for the first half of the class period, using our fractions, using decimals, whole numbers as well. But the gist of a unit rate is you're going to be dividing to find for the 1 that you're looking for. The basic thing that we need to understand is you're determining your unit rate by your statement. Then you're using your original statement to start filling in your numbers, and then whatever you're looking for, and then you're solving. Okay? We'll see you in class.